It's going to be useful for us to draw pictures of what's happening in a program at runtime in order to understand subtle questions. One of those questions is the difference between mutating a value and reassigning a variable. So we're going to use a notation called a snapshot diagram. And in its simplest form, a snapshot diagram shows each variable in the program, like n in list, with an arrow pointing from that variable to its value. That value might be a primitive type, so n is an int, so these integers are just written as simple numbers. Or it might be an object type, so list points to an array list. We show that as a circle that has the name of the type in it. But object values often have their own internal variables, and we'll use arrows pointing out in order to show the values of those internal variables. So for example, an array list of integers has essentially a reference for every element of that array list. And at this particular point in time, there are 3 elements in that list, so we'll index them 0, 1, and 2, and they point to other values, 3, 10, and 5. Now the diagrams in this course are all going to come out of examples from Java code, but this notation is actually really general. It's a general way of thinking about variables and values and objects in programming, so you can use it for a variety of different languages. Now it's going to give us a way to visualize the difference between changing a variable, reassigning a variable, and changing a value, that is, changing the internals of an object. So when you assign to a variable, what you're doing is changing where the variable's arrow points, and you can point it to a different value. So initially, when we declare n and initialize it to 3, this arrow, n as arrow points to 3, but then when we reassign it, when we compute the next value of the hailstone sequence, for example, and reassign n to 10, that means this arrow goes away and now there's an arrow pointing to 10. And then when we do the next step, which is to divide by 2 and get 5, again we get rid of that arrow pointing to 10 and we point the new arrow to 5. So we're not changing these numbers, what we're doing is changing where n's arrow points. That's what an assignment does. Now when we change the contents of a mutable value of an object that has internal variables, what we're doing is changing the arrows that point from inside that value. And that's called mutating the value. So for example, for a list, we create that list initially and it has nothing in it. And then when we do an add of an element to it, well, that's going to create this arrow here from element 0 to the value 3. And then if we add a 5, that's going to create an arrow here from element 1 to value 5. And then if we go back and set, that is change the element at index 0 and point it to 9 instead, well, that will get rid of this arrow and it will point to 9 instead. And you notice in all of this that the list variable is still pointing to the same array list object. So we're not reassigning this variable in the same way that we were reassigning n. Now, some of these variables, some of these objects that we work with are immutable and some of them are mutable. So that means, can we change their internals or not? So for strings, we can reassign a variable that points to a string object, but we can't actually change the internals of that string object. So when you run code like this, that adds a letter to the end of a string, what it's actually doing is creating a fresh string object representing that extended string, and reassigning the variable s to that new string object. String is an example of an immutable type. It's a type whose values are never allowed to change. The internals of this object can never change once they've been created. Immutability is a major design principle we're going to talk about a lot in this course. In a snapshot diagram, we're going to use a double border on the object to indicate that it's immutable, that you can't crack it open and change what's inside. By contrast, there's another class in Java called string builder. And string builder also represents a sequence of characters, but it has methods that allow you to change the value of that object. The same way that we were changing the value of this array list up here, you can change the value of the string builder. So you can start with a string builder that's just A, and now when you append a B to it, you're not getting a fresh string builder object like we did for strings, you are actually changing that string builder. And so SB now actually means AB here because it's pointing to an object whose value is changed. So these two snapshot diagrams look very different, and that's good because these bits of code actually behave very differently. The difference between mutability and immutability is going to play an important role in making our code safe from bugs. So now, in addition to immutable values, immutable types like string, Java also gives us the ability to create immutable references. And these are variables that can only be assigned once and then never reassigned afterwards. We use the keyword final to indicate that we want a variable to be immutable. The Java compiler has to prove to itself that your final variable is only going to be assigned once. And if it can't prove that, it's going to produce a static error. So final actually gives you static checking for immutable references. In a snapshot diagram, we're going to use, again, a double line to indicate that you can't change this. We're not going to be able to move this arrow once we've started n pointing to 5. Now notice we can have an immutable reference to a mutable value. So for example, if we changed this declaration of string builder here so that it had final in it, this arrow would turn into a double arrow, and it would say that SB will always point to this value, will always point to this object. But the internals of the string builder object can still change. So SB will always point there, but it may mean a different sequence of characters. Conversely, we can have a mutable reference to an immutable value, and that's exactly what was going on here. S is a mutable reference, it's not final, but it only ever points to these immutable values, these immutable strings, which will never change. It's good practice to use final whenever we declare the methods of a parameter and for as many local variables as we can get away with. Like the type of the variable, like the int here, this declaration of final is actually important documentation. It's useful to the reader of the code, which makes the code easier to understand, and it's statically checked by the compiler, which makes it safer from bugs. So we've got two variables in this hailstone sequence method. We've got n and we've got list. Question is, which of these can we declare final? We'll look at that in the next exercise.